So what I'd like to talk about is causal effects in the context of official statistics. I'm mainly employed by Statistical Netherlands, or the CBS, the Dutch abbreviation, which means the Institute for Official Statistics of the Netherlands. So we, as an institute, we provide a lot of information to various government departments to help them create better policies in principle. So in the context of that, you should see my talk so as a means of providing advice to government departments. So why do we feel that we need to investigate causality? Because people mostly know Statistical Netherlands as an institute that publishes numbers and tables and doesn't really do much else. But actually, we are more and more asked by government departments, well, we see these or those trends, fine, but is this caused by such and such? If we see this and that, does that mean that one phenomenon causes the other? If we have created different policies for social care, does that mean that the take-up will be better? So an evidence base for better policy decisions is not the same as just handing a bucket of raw numbers to a government department and telling them to get on with it, because that doesn't lead to anything, or it leads to precisely the wrong things, which is what we don't want. So we're interested in relationships, correlations, propensities, likelihoods of things to occur given a set of circumstances. So to translate that, we want to know about information flows, how much information flows from one indicator that we can measure as a National Statistical Institute into another one. Right, so one example of this, to be a bit more concrete, is the hypothesis proposed by a number of political parties and implemented in a certain sense by various ministries, that social care is best delivered at home rather than in centralized care home facilities. This was the hypothesis on the basis of which lots of care homes in the Netherlands were closed down. Of course, it was also meant to reduce budgets of various ministries, but in practice, that was the hypothesis. So there were the various planning bureaus in the Netherlands, which are charged with modeling the effects of policy behavior. They can run models for the expected effect that this closure might have. But of course, that is mostly based on a model that was never really tested. It was based on various hypotheses about behaviors or about economics, but it wasn't tested beforehand. So in principle, the role that CBS would have, CBS does not do predictions, by law we don't, but you could actually say, well, this is the kind of model that we would want to use for predictions. Would that have worked in the past with different measures that would have been implemented in the past? Can we actually validate that this model produces results that are reasonable? Now, that is the kind of thing that the planning bureau, they don't have the data to do this. That's not what their purpose is, but we do. So in that sense, CBS must know and understand how models work in order to be able to provide the validation process for those models. So that's our task, and then we can correct for an aging population, economic trends, etc. Because on all of those things we have data. Another example is that the fact that the Dutch economy is a very open economy. They rely very much on trade, on importing and exporting goods, on logistics. So in a globalizing economy, you might expect that any external event to the Netherlands that affects the economy is likely to also affect the Netherlands at some point. Booms and busts in the economy in various places, things like Brexit, you would expect the Netherlands in particular to be quite sensitive to such phenomena. But exactly how then do you measure such sensitivity? You can have all sorts of economic theories, but you actually want to know what has happened in the past when there were shocks. How quickly does an external shock actually propagate through the businesses, through the network of businesses in the Dutch economy? And that's not so much about planning or about models, it's really the structural information about the connectivity between businesses in the Netherlands. And that is past data, that's something that we have, and therefore we should be able to extract that from the data that we have. So in that sense, there's seeing the Dutch economy as a complex system, and modeling and collecting and organizing our data to support that view is different from what you think of as the usual thing that CBS does, but is much more important in a globalizing economy than it might have been 50 years ago or even 20 years ago. Okay. So the common problem that we then have is that we need to follow information flow, what influences what, using the data that we actually have access to, because there's limits to what we can collect. Quite often, for instance, most of the indicators that we publish and that we collect data for, they require a monthly publication. That's already very good. For some things, we now, because of the corona crisis, we've speeded up to weekly publications, but that's rare. For most things, we have monthly data sets, and for some, we have only annual data. Now, quite often, the total length of time series is less than 10 years, because on that kind of time scale, because of changes in government policy, changes in the way that data is collected or made available, there's breaks in the data, or in some other way you can't really extend for a very long time series. There are some exceptions, but in general, we don't get enormously long time series, and certainly more than 100 years, forget it. Another problem that we have is, contrary to, for instance, the physical sciences, where you can try to isolate the system that you want to measure and can isolate the information flow, we can't isolate anything. So we have to deal with the fact that whenever we measure A and B, there's probably C, D up to Z and beyond that also influence this process, and that we may not know about precisely, or may not be able to measure, even if we realize that it's probably there. So there's lots of problems that we have to deal with, because we can't isolate systems. And the word causality, as a statistical agency, we are likely to want to avoid, mostly because it has all sorts of connotations, and all politicians and ministries tend to be very sensitive to choices of words. So we try to, as a Statistical Netherlands, to work with more technical terms like an information flow. Can we determine whether there is or isn't an information flow between indicators or between phenomena that we publish something about, to distinguish whether cause and effect? Because also sometimes when you say to somebody from a ministry or government, this causes that, they automatically assume that there is nothing else that might also have a causal influence, that's what you're saying. And that's rarely what we're saying. We're just saying we've measured that this is one of the processes that is involved in a causation. So that we need to do. Okay, so in a few points, listing that we have at least 2 or more time series that we want to do something with. We have a reason to expect an influence from some one or more driving series to some responding time series. So we're really working on time series in most instances with CBS. And the driving time series could also be a kind of a dummy that explicitly makes explicit that there was a policy intervention at a particular point in time. The length of the time series, well, more than 100 samples is very, very rare indeed for us. Mostly we have to deal with noisy time series, and the noise is not necessarily normal distributed. And the influence, the driving and responding, that connection may very well be nonlinear. So one of the tasks that we set ourselves was, is there a statistical test that you can involve, that you can develop, that will allow you to test the hypothesis, a null hypothesis that there is no information flow from the driver to the responder. And that is work that I did together with a number of people listed here. One of the reasons, well, we have lots of sensitive data, and this was a kind of public partnership with a university department. So we had to do this on data that was also publicly available. So we decided to work on the earthquake data in the Groningen area of the Netherlands, where the earthquakes are caused by gas extraction from the gas field below the province, and there have been various government interventions to try and limit or change the way in which the gas was extracted. So you could see whether that has made any difference to the frequency or the severity of earthquakes. So okay, that's what we try to work on, so what I want to stress is that because even here the time series is relatively short, all of the standard methods, Granger information flow, etc., they tend not to work very well because we have too few data points to really quantify an information flow. So we always by necessity, we then have to restrict ourselves to just a simple hypothesis testing. Then there's all sorts of technical details. I don't know how much time I'm already talking. Feels like a long time.
You're a bit over time, Frank. If you could wrap up, that would be great.
Then I'll skip these technical details. We can discuss those later. In essence, what I want to say is that yes, in principle, we found a way of doing it, even with a limited amount of data, that you can say something, but you have to rely far more on knowing something about the actual form of the relationship between cause and effect. So you have to part of your modeling and your causation has to be, well, this causes variable A causes a change in variable B in precisely this functional form. If that is the case, then you can test, is this a valid hypothesis? So you test both whether that functional form is possible and whether then the causation can be demonstrated given the behavior of the errors. And you also have to accept that in some cases, you simply cannot conclude anything because the data doesn't allow you to do that. So that's the kind of applications that within official statistics we tend to have to work with. And that's the extent of my talk.
Thank you very much, Frank. Nice to see how we start delving into policy problems and really kind of the application of causality